I am Beth.
Hi, Hilary Petticord here.
And we work with Science on a Sphere and SOS Explorer. Thanks for being a fan on our Facebook page. We thought we'd give live streaming a try, so be gracious with us as this is our first one. If you follow our Facebook page, you noticed that yesterday we posted air traffic on there. So what we wanted to do today was show you some of our favorite data sets using SOS Explorer here behind us.
So this is a new product that we have. It's actually a flat screen version of SOS. There's a free version for teachers online, but there's also an exhibit version. So if you want one of these in your school or whatever, but it's really fun. So I hope you enjoy taking a ride with us. So first of all, this is how it works. We've got a little touchscreen laptop. And we're going to go, what did you say? We wanted to talk about air traffic first? All right.
So this is one of our most popular data sets because it's such a fascinating view of humans on our planet. We're looking at 24 hours of air traffic activity from one day in 2007. So it's 10 years old at this point, but still a really fascinating view. And the day-night terminator's built in there so that we can see how traffic varies over the course of a day. So lots of different things to see in here. We as people are all over the place.
Yeah, when I'm talking about this one on Science on a Sphere, I often say that I love it because I'm actually showing the Earth as it is, which is half day, half night. Mm-hmm. So many of our data sets, we sort of pretend that it's all day or all night. So this one, we can really see how the day-night terminator not only moves and how fast it moves, but also what kind of air traffic changes based on the day. So look at these planes coming from Hawaii to the west coast during the night so that you can get there at dawn.
And we're coming up on one of my favorite views as the sun rises across the U.S. We just see this explosion of air traffic as everyone takes off for all their flights during the day. Mm-hmm. Now this isn't our only data set that shows migration patterns. We have some more natural views, don't we?
Yeah, didn't you post the bird migration patterns the other day as well?
Onto the Instagram account. So if you're an Instagram follower, you would have seen this recently. Here we're looking, instead of at airplanes, we're looking at birds. Hilary, where did we get this data from?
Yeah, so this data set came from eBird, which is actually the largest citizen science organization in the world.
Wow.
Started in 2002 at Cornell Lab of Ornithology, and I mean, you'd be amazed how many birders there are in the world. So this particular data set is showing us 118 bird species.
Wow.
And so each dot is actually the center of one of those 118 bird species throughout the year. So it might be difficult to see the date up here, but we are looking at every day throughout the year.
Yeah, and just based on the land surface temperature we can see here, we can tell it's getting warmer now, so we must be in springtime moving into summer as it's heating up across the United States. Mm-hmm.
It's really cool. It would be fun to know what each one of these species are, actually. And I think you can actually go onto Cornell Lab of Ornithology page and find out a little bit more about each one of these species.
And we have a link to that from our website on the description page. Every data set we have for Science on the Sphere has a description with more helpful information. And so the link to the Cornell page can be found on our page.
So since we're looking at land surface temperature, why don't we go into looking at land temperature as it's changed, so the temperature anomaly.
And it's been really warm. I don't know about you all, but we're live streaming from Boulder, Colorado, and today our high is supposed to be in the 70s. We've been in the 80s twice recently.
Yeah, 80s twice, and we're already in a red flag fire warning. So what we're looking at here is actually stepping through the last year. And this type of a map is actually called an anomaly map, which means if it's white, it's basically normal or average. So in that small area is average. And then red, of course, is warmer than normal.
In case you can't tell what we're looking at, Hilary, do you want to turn on some country borders for us? Ours are white right now, and they're hard to see. So we're looking at the United States, And this is the temperature anomaly that we had for February. So almost the entire United States was significantly warmer than normal this past February. So a pretty dramatic view there.
That's a dramatic trend. Yeah, let's see what the rest of the world looks like. I haven't really been paying attention to the rest of the world's
Looks
weather.
like Asia and Russia definitely was seeing much warmer temperatures as well. A little cooler, actually, in parts of the Middle East and Africa there. But for the most part, very warm February across the planet. One of the concerns, certainly in this area, is a lot warmer and we're not getting the snow we expect, is fires. We actually just had a fire over the weekend in Boulder, really close to here. You could see the smoke right from here. Do we have anything that shows fires?
I actually just moved to the mountains and I'm really worried about fire. So yeah, let's look at the real-time fire data set. So this one might be a little bit more difficult to see, but we're looking at, I believe this information comes from satellites, right?
Really?
Yeah.
How can we use satellites to detect fires?
So fires are a really interesting thing. Satellites are able to see infrared radiation, so that is heat. And fires are really a lot hotter than, for instance, the ground versus the air, where they also can use infrared for finding clouds. So it has a thermal signature that allows us to see where fires are happening. And so I believe it's like a 500-meter region, each of these little tiny dots, where there is a fire happening. So, so you can see the fires really slowed down a bit over the winter. So we're going to kind of see...
So we're in the winter now, not a whole lot of activity.
Not a whole lot of activity. But if we back up to last summer, you could see a little bit more activity. Of course, we kind of had a wetter summer last year.
So are there other parts of the world where we see more fires going on?
Well, let's see. Where would you think we would see a
Whoa,
lot
check
of
out
fires?
Africa. What's going on there?
I think this is probably sort of slash and burn farming.
Yeah.
What do you know about it?
I think you're right, that it's slash and burn agriculture that we're looking at here. It's really pretty impressive to see from this view. It's amazing what we're able to do with satellites. What else can we do with satellites?
So we can see an amazing amount of different things with satellites. So let's just pick one of our random other real-time data sets. So this is a really cool one because it's not something that you think about very often, which is the primary productivity of the ocean. That is, how is the ocean plant life changing throughout the year?
Okay.
So a couple of questions for you, Beth. What do you think is the reason why there seems to be, and let's just talk about what the color means first of all. So you probably can't see the legend here, but this is not an image. It's not a picture that's generated from satellites, but rather it's a picture of data, right? So we're actually looking at chlorophyll concentration.
And what's chlorophyll concentration?
Well, chlorophyll is, gosh, help me out here. So it's like it's the green pigment that is a byproduct of photosynthesis, I believe.
Yeah, so we're measuring the greenness of things. And so where we see a lot of green in these images, that's where we have a lot of plant life.
Right.
In the oceans.
Yeah, so like phytoplankton, etc. So my question now for you is, why do you think there's more green near the land than there is in the middle of the ocean?
Well, I think part of it is going to do with people. And where rivers are outputting, there's a lot of fertilizers and nutrients that are on land that are running off into the water. So if we look at somewhere like the base of the Mississippi, we see a really high chlorophyll concentration. So that's part of it, is people.
Fertilizers and farming, absolutely. But then there's also a natural component, right? So there's the sediment that's actually streaming out, or the runoff in that is also partially just sediment. So there's nitrogen and phosphorus and carbon in that. So a little bit more nutrients for that blooming to happen.
And then we're also going to see upwelling, right? So like off the coast of South America, we've got cold, nutrient-rich water coming to the surface. And so we see really high chlorophyll concentrations in that area as well.
Yeah, I would think, you know, it's one of those interesting things, if we pause this actually, looking at South America, I feel like whether or not you have some background knowledge kind of helps you with some of the interesting things going on in South America. So one thing, really, we consider the continental divide, where the mountains are in the United States, to be more or less in the center, obviously in the west.
Sure, through Colorado.
Yeah, so where the rivers, in other words, on the eastern side of the Rocky Mountains move east and south, and then the rivers flow west on the west side, right? So what's interesting about South America, I'm pretty sure, is that the Andes are actually really close to the western coast.
So
all of that Amazon is draining to the east.
Yeah.
So this is actually from runoff and from wind and such.
And then that would be upwelling.
That would be upwelling, yeah. So when you talk about wind blowing things off, you see a lot happening here. And one of the reasons that you see these areas of no data, so this is kind of an area of no data because
Cloud cover.
Cloud cover or dust. Yeah, and dust causes clouds. So, yeah.
But we're working on improving this product, so you'll notice in later images, they're doing a better job of being able to get information even on the cloudier days, so it's getting filled in more. So the ocean's super fascinating. Can we load my favorite ocean data set?
Yeah, absolutely.
So my favorite ocean data set are the sea surface currents that are colorized based on temperature. So we were just talking about upwelling off the coast of South America. And if we look over here, we can see these currents that are seemingly appearing off the coast and then heading westward. That's where all this cold, deep water is now coming to the surface and moving along. What's a favorite feature of yours in this data set?
Oh, this data set, there's so much. So the Gulf Stream obviously is really interesting. Because it goes all the way across the Atlantic Ocean, making these places a lot warmer than these places, right? So Labrador isn't quite as popular in your mind as Ireland, right?
Yeah.
But partially that's because it's warmer, a little bit more temperate there. But I love this part. Yeah, so this is actually the Agulhas Current. Down the coast of Africa. And then because of the way that the land comes down and the wind blowing and the ocean gyres, all of that combines to form these amazing eddies. And I have no idea what these are like.
I've heard if you're a fisherman, they're a great place to be because a lot of nutrients get wrapped up in those, and that your fish catch is going to be a lot better.
Yeah.
But also if you're a sailor, it makes for some crazy currents that you have to get through.
Yeah,
so,
absolutely.
A really fascinating view. So this is just a little taste of what you can do with Science on a Sphere and SOS Explorer. We have a huge data catalog, lots more to explore. So I would recommend hitting up our website. I think Hilary's got it written down for you here. So visit our website. This is capitalized here, SOS and that E. Or just Google SOS Explorer. You'll find us.
If you just want to go to the data sets, go to the first part and click on the data sets tab. And we have 550
or so?
80, something like that. There's a lot. We're adding them almost daily. So have fun, and thank you for following.